grade 7 and 8.
Okay, are we ready to begin now or?
It's 10 minutes. 10 minutes. Okay, so grade 7. So, ready? Down.
Yes.
We can begin.
Okay, sounds good. So today we will be solving some practice problems for the BECE, science to chemistry part of it. So I have around 50 questions ready, so we will go through them pretty quickly. So here, let's start with the first question. So, the building block of a material with the smallest unit of matter that retains the properties of an element is it A, an iron, B, an atom, C, a molecule, or D, a proton? Does, does anyone know the answer to this question?
Iron.
No, it is not an iron. Um, it is actually B. It's an atom. So the building block of materials, atom is the smallest unit of matter. So it's the smallest unit of matter, and matter is anything that has mass and takes up space. And it is made up of tiny particles called atoms. And atoms are the smallest unit of matter. So and matter exists in different states, such as you know, solid, liquid, gas. And there's a fourth element called plasma, and can undergo physical and chemical changes. So everything around us, such as air, water, and living organisms, are composed of matter. This is a brief introduction of matters, and remember that atoms are the smallest particles of matter. See here, I have defined an atom to be the smallest unit of matter that retains the chemical properties of an element. So that is an atom. And it consists of a nucleus containing protons, which are positively charged, and neutrons, which are neutral in charge, and surrounded by electrons, which are negatively charged. I have a sort of diagram after this. You might have seen this already, but these are the basic properties of an atom. And atoms combine to form molecules and make up all substances in the universe. So a lot of these atoms can combine in different ways to form molecules, which are just combinations of atoms. So here is what the scientists believe an atom looks like. And of course, we can see the protons, which are positively charged over here, which is marked blue, and neutrons, which are red over here. And protons and neutrons, you can see, are in this nucleus, which is in the center of an atom. It's the core of an atom. And surrounding it, there are electrons orbiting around. So this is the basic structure of an atom. For example, let's have water, which is H2O, and it is a matter since it's a liquid. It consists of two hydrogen atoms and one oxygen atoms. And this makes up one molecule of water. This is a water molecule, H2O. And you can see it consists of multiple atoms. In this case, two hydrogen atoms and one oxygen atom. You can see it combining into a molecule. Another example might be nitrogen gas, which is a gas matter, and it is N2. It consists of two nitrogen atoms. This is showing you that there are multiple possibilities how atoms can combine to form molecules. Now, we see that in N2, it consists of two nitrogen atoms, and we have figured out H2O, it consists of two hydrogen, one oxygen. Now, let's try this question. So, how many atoms are present in H2O2? So, how many are there in total? Does anyone want to answer this question?
Well,
Yes, that's right. For this, the answer is four. Because
yes.
two hydrogen atoms and two oxygen atoms make up four atoms in total in this molecule H2O2. That is right. So, third question is which of the following substances are matter? So here are the choices. Is it hydrogen? Is it air? Or is it stone? You can choose multiple. So A says one and two only. Is it only hydrogen and air that is matter? Is it hydrogen and stone? Or is it air and stone? Or is it all of them? Is everything matter? Does anyone want to answer this question?
It's D.
Yes, that's right. It's D. Because matter is anything that has mass and takes up space. And we have discussed that solid, liquid, and gas are all matter. So it is right that it's D, all of the three, one, two, and three, they are all matter. Does anyone have questions so far? Because I will continue on to the next question. Okay, if there are no questions, let me move on to this fourth question, which is the two main particles in the nucleus of an atom are they neutrons and protons, or neutrons and electrons, shells and neutrons, or electrons and protons?
It's A.
Yes, that is right. It's A. Since I have a diagram here again, in the nucleus, which is at the center, the core of an atom, there are protons and neutrons, which is A, like you said. And on the outside, there are electrons orbiting around to form the atom. So this is the structure. We're reviewing the structure of an atom. And remember how protons are positive and electrons are negative. That is why electrons can orbit around the nucleus because they have opposite charges and they attract each other. And neutrons, they don't have any charges. Now let's move on to the fifth question, which is an atom of an element has a neutral charge because is it protons and electrons are the same particles, proton number and electron number are the same, or a neutron number and proton number are equal, or is it because the electron number and neutron number are equal?
A.
The Here, I think you answered A, but here A says protons and electrons are the same particles. So this might be a little trick question since they are not the same particle, but the numbers are the same. That is why B is correct. Um, since again, protons are positively charged, electrons are negatively charged. So if the numbers are the same, then it will have a neutral charge. It won't have a charge at all because they cancel out. And A is not correct again because it's not the same particle. It's just the numbers that are the same. Yeah, you can see that this actually needs one more electron. And you can see the number of protons should match the number of electrons to have a neutral charge. Here, an atom has 20 nucleons and 9 protons. What is its neutron number? And nucleons are um, neutrons and protons combined. So, does anyone want to answer this question?
C. 11.
Yes, that's right. You said C11, which is right because nucleons are protons plus neutrons, and we simply subtract a 9 from 20 and we get 11, which is C. That is correct. We have seen before, a nucleon are particles found in the nucleus. It's protons plus neutrons. An example is a carbon-12 atom, which has um, an atomic mass of 12, which means that there are 6 protons and 6 neutrons, and therefore the combination of these two, 6 plus 6, just 12. So we have 12 nucleons. And from this, does anyone know how many electrons we have in this carbon 12 atom? It will not be 12, you said that. Since electron numbers should equal proton numbers. Just Again, 6. So remember always that electron numbers should equal proton numbers when it is in its neutral state. Because, again, if it's neutral, it does not have any charge. So the proton numbers should equal the electron numbers to not have any negative or positive charges. So remember always proton numbers equals electron numbers. But neutron numbers can differ a little bit by the number of nucleons, like we have figured out before. So if it's given the nucleon, which is 12, and if it's given protons, which is 6, we can find the neutrons by subtracting 12 minus 6, and we can calculate the number of electrons by 6 protons, so there are 6 electrons. So that is how you can figure out all the parts, number of parts of the atom. Is everything clear so far? Does everyone understand this until now?
Yes.
Okay, sounds good. Now, question 7. Which of the following elements has 4 electron shells? It's a new type of question. Does anyone want to try this?
E.
The answer is actually A, and this is a little difficult without seeing the periodic table, which is a period. This is a periodic table, and from this we can figure out the number of shells. So without this, it is a little difficult to know the answer because we have K, which is potassium. We have Al, which is aluminum. We have P, which is phosphorus. And we have B, which is boron. So let's locate each of these in the periodic table. So potassium K is over here. Does everyone see this? It's number 19. And phosphorus P is over here. And aluminum is over here. And boron is over here. But how do we know the shells from these? Well, to determine which element has 4 electron shells, we need to check the period number in the periodic table. And the number of electron shells an element has is equal to the period number. So period number increases by the rows on the periodic table. So here, this is period 1. It goes down by row. Period 1 has H hydrogen and He helium. And it increases as we go down. In period 2, which has 2 electron shells, has lithium, beryllium, boron, carbon, nitrogen, oxygen, fluoride, and neon. All of those are period 2, and so on from period 3, the whole row, and period 4, and increases as the rows go down. So, because potassium has period 4, you can see period 4, it has 4 electron shells. Aluminum is in period 3. Let's check it. Yes, aluminum is over here. And it's in the 3rd row. Therefore, it has period 3 and has 3 electron shells. Phosphorus was also in the same period. It has 3 electron shells. And boron is actually above. It's in the 2nd row. Therefore, it has period 2 and has 2 electron shells. That is how we can figure out the number of electron shells of an atom. Is everything clear? Does anyone
Yeah.
understand? Okay. So, mm, I will share this slide because you will need to get a little familiar with the periodic table. This is very important in chemistry. So this tells you the atomic number, the atomic mass, the number of protons, which equals the numbers. And this is very useful to have. So I will share this after this class. So let's um yeah, this is just an example of how the shells might look like. We have this form, this diagram that shows explicitly the shells. So we can see here's the nucleus, here's the first shell, here's the second shell, and the third shell. So you might see a little bit of a pattern. So the pattern is we have two electrons in the first shell. The shell is where it holds certain numbers of electrons. You can see the first shell has two electrons. The second shell has eight electrons. The third shell also has eight electrons. And it actually moves further and further. So it's 2, 8, 8, 8. And then it moves on. It moves on to 18 here because we can see the number of atoms in the first cell. You can see there are only two atoms, hydrogen and helium. That means it will only have two electrons in the first shell. We can see there are eight atoms in the second shell, so there will be eight electrons in the second shell. And third shell also has eight atoms, so it will have eight electrons in the third shell. So 18 just shows the combination, the total number, if it has all of them filled. So this is just an example to get you familiar with the electron shells. Now let's move on to a different question about the electron shell. Which of the following chemical symbols is that of an element with 7 electrons in the outermost shell?
B.
Yes, that is right. We have B, which is 7 valence electrons, and valence electrons we will get to is the outermost shell, the electrons in the outermost shell. And we can see again this pattern. We have 2, 8, 8, and then we have extra electrons from calcium, 2 more, and we can see 2, 8, and 7. It's not at 8 yet. It's still filling up the third shell. And we can see 2, 8 for the neon and electron numbers in shell types, so 2, 8, and 6. So this valence electrons are determined by this actually you can see from the columns. So what you can do if you have a periodic table ready in front of you to determine how many valence electrons it has. Does anyone notice a pattern? you can see this first group has one valence electrons. And in group 2, we have 2 valence electrons. We can actually skip the transition metals, move on to 13. Actually, we can call this the third major column, which has 3. I have 1 valence electrons. VE is the valence electrons, the electrons in the outermost shell, and 2 valence electrons. And this whole row, this entire row has 2, the entire row has 1, and this entire row has 3 valence electrons. This whole row, and so forth. So that's 4, that's 5, 6, 7. And at the end, it has 8 valence electrons. We don't need to memorize the periodic table. I think it should be given out. If it's not, then maybe get familiar with this view. But just remember that valence electrons are determined by the columns in the periodic table. Now let's move on to question 9. The periodic table is the arrangement of elements according to increasing what?
A. Atomic number.
Yes, that is right. It is the atomic number. And we can see from here, for example, carbon. It has atomic number of 6. This is how it is present in the periodic table. On the top, it says 6. This is the atomic number, which equals the number of protons, which again equals the number of electrons. So atomic number tells you about the proton and electron numbers. And atomic mass is given to be 12.01. What we can do here is we can also figure out the number of neutrons by subtracting 6 from around 12. We can approximate there are 6 neutrons in this atom as well. We can subtract to find the neutrons. So in this carbon atom, how many valence electrons do you guys think we'll have? Valence. So this carbon, you remember, electron shells fill electrons in a pattern with 2, 8, 8, and so on. So this has 6 proton numbers, which equals 6 electron numbers. If we have 6, we can fill out the 2. The 2 is checked. This is checked. And we can start filling out the second one. If we have 8 minus 2, 8 minus 6, which we have to be 2. And we can conclude that if we fill out some parts of it from 8, we have already fixed 2, and we have 4 left, so it will have actually filled out 4 electrons in this electron shell. So we have 4 valence electrons with the carbon atom because we have filled out 2 electron shells, and since this is the most outermost shell, we have 4 electrons in it, and it has 4 valence electrons. So let me actually draw for the carbon. This is the nucleus of a carbon, and this, and then we have um, 2 electrons filled, because this has 6 electrons, we have to fill each one. This is the first shell, and in the second shell, this has the capacity to fill 8 electrons in total. But we have 6 minus 2, we have already used 2, so we have 4 electrons left. So we just fill out 4 here. 1, 2, 3, and 4. This is how the electrons in each shell looks like in carbon. So, is this clear for everyone? Just wanted to share. Does anyone have a question, or do you guys all understand?
Yes, I understand.
Okay. Just remember the pattern of 288 for the electrons in each shell. And the valence electron is the outermost electrons, which fill out the outermost shell. You can see to be 4. We can move on. And that is determined by the atomic number. Since we actually go back to the question, it was about the arrangement of elements increase according to the atomic number. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9. It's increasing by atomic number. So number 10, which of the following pairs of elements is in the same period as in the periodic table? Same period means the same rows. Does anyone know the answer to this question?
D.
It is not B, it is actually C, because if we look at the periodic table, we can actually figure this out by even not knowing the periodic table. What we can do is look at the atomic number. Let's look at the atomic number. We have first A, boron, which has atomic number of 5. And we have aluminum, which has atomic number of 13. Remember, same period means same shell. So we can figure out we have pattern of 288. Always remember the pattern of 288. We have this. Boron is in the second period because it fills out 2 and it also partly fills out 8. So it fills out 3 out of 8. So it has period of 2. But aluminum, let's see, it fills out 2, yes. We have 11 electrons left. It fills out 8, yes. It also partly fills out the third shell because we have 13 minus 10, which have 3. Aluminum has 3 more electrons in the third shell, so this is not in the same period. We can do the same for hydrogen. See 1 for hydrogen and 3 atomic number for lithium. And hydrogen only fills up the first one, while lithium, which has 3, also fills out the second one. So this is also not correct. You can see for beryllium and boron, though, you have 4 and 5. 4 and 5 are very close to each other, but do not sometimes get tricked because close atomic number may not necessarily mean the same period, but in this case, it is. For hydrogen and lithium, it wasn't because you have to test the shell numbers. For beryllium and boron, though, we have filling out the first shell, yes. Filling out partly the second shell, yes, for beryllium and both boron. So C is correct. And we can also see that 11 and 19 are also in different shells, and therefore the different period. That is how we get to the answer. And this is way easier if we look at the periodic table. In case it is not given, we can figure it out the method that I just did. But if you have a periodic table, you can see the same row means the same period. You can see boron B, which is here, beryllium 4, which is here, is in the same row and in the same period. Move on to question 11. Which of the following ions is formed by the loss of 2 electrons? So we are moving into questions about ions. And positive means losing electrons, and negative charge means gaining electrons. So which ion has lost 2 electrons? Does anyone want to answer this question? The answer,
A.
yes, that's right. The answer is A, because we have calcium, which has, you can see 2 plus, and 2 plus, since plus means losing electrons, calcium 2 plus has lost 2 electrons. Remember how electrons are negatively charged. That is why if you gain electrons, it doesn't become positive. It becomes more negative if it gains electrons. So if it gains electrons, then it has more negative. But if we lose electrons, it becomes more positive. So more positive. And the whole charge of an atom. An atom is normally neutral. It does not have any charge, but if it loses or gains electrons, the charge changes. So if you gain electrons, it becomes more negative. If it loses electrons, it becomes more positive. Okay, so we talked about loss of electrons leading to positive ions and gain of electrons um, ending up in negative ions. So positive ions are called cations and the negative ions are called anions. So if the question asks, what is a cation? Then you have two answer choices, calcium 2 plus or C, potassium plus. Because they're both positive, they're called cations. Negative ions are called anions. And yeah, it results from change in electrons from the neutral atom. You can see sodium atom, it loses one electron at the top. It becomes sodium ion, which is Na plus. For fluoride F, it gains an electron, so it becomes this, the F minus, the fluoride ion. Since it gains electrons, there is a uh, so question 12, when an atom loses an electron, the ion formed is called, is it an anion, is it a cation, or is it molecule, or
Is that cation?
um, here? Yes, that is right, because if you look at the diagram again, loss of electrons lead to positive charge. Therefore, it is cation. That is right. Let's try this question. An atom, any atom X is forms bond by losing one electron. The charge on the iron form is what will be the charge of this atom. Yes, that's right. C, positive one, because losing one electron, it lost one electron. So it is positive one. So the chemical formula of an aluminum sulfide is Al. We don't know the number of aluminums joining sulfur, so ALY and S3. Can anyone find the value of Y? This might be a little tricky. Um, Let me actually go through this problem. So we have aluminum. Remember, aluminum has 3 valence electrons. So in order to be stable, for atoms to be stable, they need to have 8 electrons in the outermost shell. It can also have two, that's the special case for helium, but most of the time it needs to have 8 electrons in the outermost shell to be stable. So every atom wants to have 8 electrons in their outermost shell. Aluminum, because it has 3 extra electrons, it wants to lose those 3 extra electrons. What happens if aluminum loses 3 electrons? It becomes aluminum 3 plus. For sulfur, it has 6 electrons in the outermost shell. Does that mean sulfur has to lose 6 electrons? No, that will be very inefficient. Since 6 is closer to 8 than to 0, sulfur wants to gain electrons. Sulfur therefore gains 2 electrons because 6 plus 2, it makes up 8 in the last shell, which is stable. So it ends up in S2 minus. That is the major way we can figure out the ion of an atom. The ion charge. But how can we solve this problem? What is Y? An AlY_S3. Because sulfur ion is given to be 2 minus. It has -2 charge. What we can do here is multiply by 3 because there are 3 sulfur ions. And if we multiply by 2, -2 times 3, we have -6. But this molecule is neutral. So aluminum must have a +6 charge to cancel the -6 charge of the sulfur ions. So we have ALY equals +6. But remember that aluminum has an ion 3 plus, since it wants to lose 3 electrons. Therefore, if we divide 6 by 3, we have 2 aluminum ions. So the answer is B. It requires 2 aluminum ions. Let's actually take a simpler question. This is a little complex, so some of you might be confused. That's why I made a simpler problem. So let's look at this. For example, we have sodium, Na, which is over here. I highlighted in red. It has 1 valence electrons because it is in group 1. It is in column 1. We also have calcium, which is in column 2. It has 2 valence electrons. We also have sulfur, S, which is over here. It's in the 6th column, so it has 6 valence electrons. And chloride has 7 valence electrons over here. What this means is that sodium will have +1 charge. It wants to lose this 1 electron to make it a neon. Sodium really wants to be neon, so it loses 1 electron. Calcium is also close and wants to become valence electron of 8. To do that, it has to lose 2 electrons. So it becomes calcium Ca2 plus as an ion. In chloride, it wants to lose one, it wants to gain one electron because it's closer to become 8. It has 7 electrons. It only needs one more electron to become 8. So it gains 1 electron. For sulfur, it gains 2 electrons. So this is the ionic compound of these 4 elements. If we have Na and Cl combined, sodium and chloride combined, what does it form? It forms NaCl because +1 and -1. You don't need multiple ions. You can just add the two together and it cancels out. What about sodium and sulfur if we want to combine sodium and sulfur? Sodium has +1 charge, but sulfur has -2 charge. So we need 2 sodium ions and 1 sulfur ion. To make it 0, we want to make the charge 0. All of these are 0, but the methods are different. So +1 -1 is 0, +2 +1 times 2. Multiply this by 2, then -2. This is +2 -2 +2 and -1 times 2. All of these have 0 charges, and we want to maintain that. And we can combine, again, calcium and sulfur, +2, -2, to make it 0. We can combine calcium and chloride, +2 and -1. We need 2 -1s, so we have Cl2. This becomes CaCl2 if you combine ions. Does anyone understand up to this point? Wanted to make sure. Okay, I hope this made a little clear. Let's move on to question 15. Calcium oxide and water reacts to form calcium hydroxide. The formula for this product is yes, it is B. I actually have it given out here, but how did we get this? So actually, this is how, for example, calcium and hydroxide. So we have calcium and hydroxide, which is OH, combining. But remember, we know Ca, we know calcium to have +2 charge. We saw that. What about OH? OH hydroxide is actually special because this whole molecule has a negative charge. That is why I put parentheses around OH. This whole thing has -1 charge. And remember how we combine these two. Hydroxide, OH, has -1. Calcium has +2. What can we do to make it 0? We need to have 2 hydroxide ions. We need to multiply this by 2. This becomes negative 2 plus 2, which equals 0. We have it. Therefore, we need 2 hydroxide ions. So the formula for the product is CaOH2. Is this making sense for everyone? Yeah, I hope this is clear. Um,
Yes, sir.
okay, seriously. I have things summarized here. What we have dealt with so far is called an ionic compound. So compound is actually formed by combining different types of atoms. And specifically, we have worked with ionic compounds. We have worked together combining multiple ions to form a different compound. It forms when positive ions, cations, and negative ions, anions, attract each other due to positive charges. So we have seen sodium and chloride, NaCl, calcium and oxygen, CaO, which is called calcium oxide. We have also seen magnesium Mg, which has 2 plus charge, and chloride, which has -1 charge. We need 2 chloride, so we multiply this by 2. So we have MgCl2. We can also have potassium and iodide combining to form an ionic compound of potassium iodide, just K plus and I minus. And we have some examples here of cations, examples of anions. If you see a pattern, then you can see cations are all located on the left side of the periodic table because it's easier for those atoms to lose electrons rather than gain. On the right side of the periodic table, however, has the tendency to gain electrons since it's closer to 8 and it's closer to gaining electrons rather than losing them. Consequently, the right side is called the nonmetals and the left side are called the metals. So metals are cations, nonmetals are anions. Let's try question 16. So the number required to make the following chemical equation balance this is about balancing chemical equations. Let's actually do questions until balancing equations and we can see from that. I will give you a hint for this one. What will need to be multiplied here next to oxygen? What is the number here? To balance this chemical equation. Will be A. It needs to have 1/2 multiplied to O2 because on the right side it has 1 oxygen. But on the left side of this equation, it has 2 oxygen atoms. So we need to multiply by 1/2 to make the number of oxygen atoms equal. hydrogen atoms are already equal, since we have H2 on the left, H2 on the right. I went through this on the next slide. So, about balancing chemical equations. So we have H2 plus O2, which equals H2O. O2 has 2 oxygen atoms. And to balance oxygen, we need 2 H2O molecules. We need 2 water molecules. So we put 2 in front of H2O. We multiply by 2 to balance the oxygen. So 2H2O now has 2 oxygen atoms, but also 2 hydrogen atoms. What can we do with that? To balance hydrogen, we need 2 H2 molecules on the left. So if we multiply by 2, we have 2H2 plus O2, which goes to 2H2O. And this balances the equation because we have the number of atoms equal on the left and on the right. We could use a half of an oxygen, which is what they did. Instead, we can write H2 plus half of O2 equals H2O, which is also correct. Let's have a little more different examples. So atoms neither appear out of nothing or disappear out of nothing. So let's have an example. Um, Let me actually work out this. So H2O2 goes to H2O. Let's work it out ourselves because words can be misleading. So, how many hydrogen atoms on the left side? There are 2. You can see from here, we have 2. How many hydrogen atoms on the right side? There are also 2, right here. The right side, there are 2. Let me separate this. How many oxygen atoms on the left side? You can see it has 2. How many oxygen atoms on the right side? It's like a puzzle. It has 1. So we have same number of hydrogen, which matches. Good. This is good. But this oxygen atom is not good because we don't have the same number of oxygen. Remember, atoms can neither be created nor destroyed. So the number of atoms on the left, the types of atoms on the left, and the types of atoms on the right must equal. But 2 does not equal 1. What can we do here? Our solution was to multiply H2O by 2. So we have 2H2O. And now we don't have oxygen as 1, but rather we have oxygen as 2. Is this clear? No, this is not done because we actually multiplied hydrogen by 2 as well. So hydrogen number does not equal 2. It actually equals 4 because we have 2H2O if we have two H2 molecule, we have 4 hydrogen atoms. But now, although this second part is correct, we have matched the oxygen numbers, but this is not equal. The hydrogen number is not equal because we have 2 on the left side, 4 on the right side. What can we do here to match it? We can actually multiply this left H2 by 2. We multiply this by 2. We have H as 4. We have 4 hydrogen atoms because we have multiplied 2 on the left hydrogen molecule. It's not 2 anymore. Now we have everything matched. Hydrogen is 4 on the left side, 4 on the right side. Oxygen is 2 on the left side, 2 on the right side. What the question did was it actually divided everything by 2. You can do that, but that might be a little unnecessary, but we can divide everything by 2. This cancels out to be 1. This also cancels out to be 1. That is why the correct answer was 1/2 multiplied by the oxygen. Does this make sense to everyone? Everyone understand so far? Okay, I hope it was clear. Let's try another one by yourself now. I'm not going to be helping on this one. So question 17, which of the following chemical equations is balanced? So I will let you guys solve this question. Yes, it's D. That is right. If you said D, that is correct. We have worked out here. From A, we have H2Cl2 goes to which turns into HCl. This is not correct because we have 2 hydrogen atoms on the left side, 2 chloride atoms on the left side, but only 1 hydrogen chloride atom on the right side. We actually need to multiply 2 to make it balanced, but A is not balanced because it does not have the 2. What about K2O? Goes to K potassium plus O2. This is also not correct. Because we have 2 potassium ions atoms on the left side and 1 potassium atom on the right side. So these numbers are not equal. What about magnesium, Mg plus O2 equals MgO? We can see straight away that 2 does not equal 1. If it does not have anything, it just means 1. This is not balanced. To balance this, what do we need to do? We can actually multiply the right side by 2. This becomes 2 MgO. But this balances the oxygen, but this does not balance the magnesium because we have 2 magnesium on the right side and 1 on the left side. If you look at it at this step, what we can do is multiply 2 again and magnesium. This balances the equation. You can see it yourself. 2 magnesium, 2 oxygens, and 2 magnesium, and 2 oxygen. Now this is balanced, but this first part was not balanced. That is why C, B, and A are all incorrect. The correct answer was D, like you guys said, which is 2Na plus Cl2 equals 2NaCl. You can see there are 2 sodium atoms on the left side and 2 sodium atoms on the right side. You also see 2 chloride atoms on the left side and 2 chloride atoms on the right side. So this all matches and it is correct. Is time okay? Do we have time for one more question? Um, when do you guys have to go to next class or I just wanted to make sure how much time we have left for you. Can anyone tell me like how much time we have left, or is there limited time that I can do? Hello, can anyone hear me? Can you hear me? Hello? Can everyone hear me?
Kevin, your voice is not clear.
Hello?
Yeah, we can hear you now.
Oh, you can hear me now? Okay. I think we can
Know the answer, you see it.
do it until 2:30 for your time. Is that okay? Or do you want more practice?
Yes.
Hello? Can you hear me?
Yes, we can hear you.
Okay. So, is it okay if we continue until 2:30 for your time? Or do you want more?
Yes, 2:30 is better, so we can continue till 2:30.
Okay, we can go to 2:30. And
Yeah.
Yeah, let's try this question then. Question 18. When an unknown solution reacted with magnesium, a gas was produced. Which of the solutions could be the unknown solution?
A.
This answer is C. What this is aiming for is the reaction of magnesium with hydrochloric acid. This might be a little complicated, but just remember how magnesium is more reactive than hydrogen. So magnesium can push out the hydrogen from HCl. This is not too important, but you might need to know some of the reactive um, series from the reactivity series. We have multiple different atoms reacting, and it determines how well the atom reacts. So we have potassium, sodium, lithium, and calcium, one of the very reactive metals. We have some less reactive like copper and hydrogen. Just remember that some metals are very reactive, like these ones. Some metals are not that reactive. And for this question, the ion that causes hardness in water is, does anyone want to?
B.
Yes, that is right. I have listed calcium and magnesium ion causes hardness in water. You might need to just memorize these two. This calcium, magnesium, Ca2 plus, Mg2 plus. They cause hardness in water. So the answer is B. So question 20. Which of the following chemical symbols can be used to remove permanent hardness in water?
B.
Yes, we have given here it's Na2CO3. It's called sodium carbonate. Answer is B, which is also called washing soda. And by using sodium carbonate, Na2CO3, it causes to remove the hardness in water. Let's try this other question. So what is the systematic name of the compound CO?
David, can you go to the previous slide? The previous one.
This one? Okay.
Yes, yes, yes. They want to write something there.
Ah, okay, yeah.
Let me switch it. Okay, you can move on.
Yeah, this is question 21. So the answer is actually given to be carbon 2 oxide, which is B. And this is because um, CO, this is called carbon monoxide. And in systematic naming, however, we use oxidation states of the element. So for carbon, just remember that it has oxidation state of 2 when it is with oxygen. That is why it's carbon 2 oxide. Um, for example, carbon dioxide, if we had carbon dioxide, the oxidation number of carbon would be 4, and it would be carbon 4 oxide. This is just get to know familiar with the systematic naming. But let's try this question, question 22. A student complained of stomach upset, was given first aid with MgO2, boldly written on it. What could be the common name of the first aid the student was given? This is B.
B.
Yes, that is right. Because we have Mg magnesium and magnesium hydroxide, which is the name of this molecule, is a base, and it is commonly used as an antacid and looks antacid, and laxative. And it is called, the common name is milk of magnesia because it has a sort of milky appearance when it's in water. And it helps neutralize stomach acid and relieve some stomach upsets. So we have on the picture right, you can see milk of magnesia have this milky appearance, and it contains magnesium hydroxide. You can see over here. Just remember that that is the common name. I'll just wait for some of you to write this down if you need it. For this, you can just write down milk of magnesia equals MgOH2. Think on now. You're ready. Now let's see question 23. Two unknown solutions labeled A and B were brought to a JHS 3 class. It was observed that in solution A, red litmus paper changed color to blue, while in solution B, red litmus paper retained its color. It had the same color as red. What could be the content of solution A? We were now moving on to acids and bases. So does anyone know the answer to this question?
It's B. B.
Um,
It's B.
So
Short solution.
this is actually not B, it's C. It's baking soda, but this is a little tricky because you need to know what is acidic and what is basic. So let's review litmus paper color change. So litmus paper color change um, is showing a change in pH, the concentration of H plus, and it determines if the solution is acidic or basic if the paper is dipped in the solution. In acidic solutions, the litmus paper changes to the color red. So it has pH of less than 7. So blue litmus paper turns red in acids, and red litmus paper stays red in acids. Some examples of acids are lemon juice. We have seen orange juice. Orange juices are acidic. And other examples are vinegar and hydrochloric acid. Those are all acidic. It releases H plus to the solution. Then it turns the litmus paper to red. For basic solutions, it has pH of greater than 7 and it turns the litmus paper blue. Red litmus paper turns blue in bases, and blue litmus paper stays blue in bases. Some examples of bases that are very common are soap, baking soda, ammonia, and sodium hydroxide is another example. We have seen here, we can answer this question now. We have C as baking soda. Remember how this is basic. So, in content of solution A, red litmus paper changed color to blue. What does that say? That means the solution A is basic. And baking soda is basic. That is why the answer is C. But last one, before we move on, we will have to probably end here because we are close to 2:30. But in neutral solutions, the pH equals 7. There are no changes in pH. So both red and blue litmus paper do not change color. For example, pure water and salt water. Simply mixing salt does not change the pH. It may turn it a little basic, but it's not of significant difference. So here is an example. Dipping blue litmus paper into acid turns it red. For base, dipping red litmus paper into the solution turns it blue. I have this one more question about acids, and we can call it a day for today. So, last question. Which of the following statements about acids are correct? Is it 1, 2, or 3, or all of them? They turn red litmus paper blue. They can be neutralized by bases. And citrus fruits contains acids.
C.
C.
It's not B, but it It's oh yeah, it's B because that is right. You have acids. So acids actually turn blue litmus paper red. So it this red litmus paper turning blue is for bases. For acids, they turn blue litmus paper to red. That is right. The answer is B. The second one is correct. They can be neutralized by bases. Acids and bases react. Um, they form a neutralization reaction. And for three, we have citrus fruits contain acids. And that is correct because citrus fruits, we have discussed orange juices too. Citrus fruits usually contain acids. And this is the last question about the acids. So we can do until this one. So this will be the final question. One of the properties of acids is that they, is it A, turn blue litmus paper red? Is it B, have no effect on the litmus paper? Is it C, turn red litmus paper blue? Or is it D, all neutral to litmus paper?
A.
The
A.
answer is A. Yes, that's correct. Because you see, the properties of acids, like I've said multiple times, is that blue turns into red. That is why A is correct. And C is not correct because it says red turns into blue. That is for bases. So for acids, for C to be true, red litmus paper should remain to be red, not blue. If it turns into blue, then it's a base. So yeah, that is the end for today's set of questions. We ended at 25, which is around half of the questions. So next week we will continue this chemistry and then move on to some of the physics questions as well. Does anyone have any questions for today?
This no.
Okay, was today's topic, um, was it easy or was it difficult? Um, or was it already familiar? Or was the topic new for anyone? Yes, can you hear me?
Was a disconnection. I yeah, yeah.
Um,
You
how
can
did
hear you
they?
now.
Yes, I can hear you now. Was today's lesson okay? Was it um a little difficult or was it already familiar? I just wanted to know.
Even
Yes.
yeah, it was okay. Just that the balancing of equations was a bit challenging. The balancing of equations was a bit challenging to them.
Oh, a
Yeah,
little
so can you hear me?
yes. Because these are the questions that are
I
on
was
the
saying that the balancing of equations was
Oh, okay. So for balancing equations, we can review again next time if they want, if it was a little difficult. Um, but yeah, we will continue this chemistry lesson next week as well. So,
okay. All right.
okay, yeah,
All
if
right.
there are no questions, I will see all of you next week.
Okay.
Okay, yeah,
Have
bye
any
everyone.
question?
If no questions, okay, and I'll see everyone next week.
Okay. Bye.